Alright, so first we want to prove an even number is divisible by 4. So let's let n be the even number. So then we have n being in the form of 2k, where k is of course an integer. So let's have a look at the square. So an even number, square of an even number is divisible by 4. Well, let's have a look. Square of an even number. So let's get that even number squared, and you can see it's 4k squared, which is divisible by 4. Since we know k squared and 4, they are both integers. So yes, that is true. How about for the second part? So prove the remainder of 1 when this... Okay, so now we're squaring an odd number. So let's let m be the odd number. And then we would have m being in the form 2j plus 1, where for some integer j. Alright, so let's have a look at the square this time. So 2j plus 1 squared, we've got 4j squared, we've got a 4j, we've got a 1. We're interested in whether it's divided by 4, so, 8. So when it's divided by 8, sorry. So let's have a look. If I factorize out, I get j plus 1 there, and then I have a 1 there. And you can see that j plus 1, remember j plus 1, is just the product of consecutive numbers. So one of them has to be even, of course. So therefore this is going to be an even number when we get the product there. So we could change it to be equal to something like, let's say 2p. It's showing it's even, and if we put that in, you can see now, oops, not with the j, because that's part of it. You can see now we've got 8p plus 1. So when it's divided by 8, we get a plus 1, we get a remainder of 1. So prove that there is a remainder of 1 when the square of an odd number is divided by 8. So yes, we do get a remainder of 1. Therefore, when m squared is divided by 8, we get a remainder of 1. Okay, so two things to note there. If our square number came from an even squared, it is divisible by 4. If our square number came from an odd number that we squared, and we divide it by 8, we get a remainder of 1. Those two things happen. So let's now have a look at a number that is made up of a squared plus b squared, and a and b are odd. So let's let a be 2k plus 1 and b be 2j plus 1, so both in the odd form for integral k and j. Then what does a squared plus b squared equal? So that's what we're interested in. Alright, so we know from part B, they're both odd and they're squared, so we could put them in this form, no problem. Okay, that's from B, so we're just adding these two odd squares here, but we really want to look at the number as a whole. So what kind of number is this? All square? Is this a squared number? Okay, so let's have a look at this. So we'd get 8p plus q plus 2. So you can see if it was a something squared, let's say something totally different squared, like p, and we've already got p, q, r, so r squared. So if this was a number squared, r squared, suppose it was r squared, if that r was odd, remember when we divided it by 8, we got a remainder of 1. So here we're getting a remainder of 2. So it's definitely, so from B, it can't be an odd squared, right? Now the other thing to note is if we put it in the form where it's a 4, so remember we had it was divisible by 4. So if I rearrange it and make it a 4, what would I have? I would have 2p plus q's. No, so I would be able to divide that part by 4, but not this part. So now I'm getting a remainder of 2, so it's not divisible by 4. So then again, from this, so from A, it can't be an even number squared either, can it? It can't be an even squared because when we had an even number squared, it was divisible by 4. So it can't be even squared. So if this number can't be an even or an odd number squared, then it's not a square number. So therefore not a square number. Again, hopefully, you can't read, but hopefully you heard what I said.